this section we're going to be talking about surface area. Let's start by introducing some specific types of figures that are known as polyhedra. A polyhedron, singular, is a three-dimensional figure or solid with flat faces. If you're looking at prisms, prisms have two bases that are parallel to each other. And whatever the shape of those two bases are is the name of that prism. So for example, in this figure, we have pentagons as the bases, the two shapes that are parallel to each other. So this is referred to as a pentagonal prism. And this next figure, the two bases are triangles, and they're parallel to each other. Notice in the triangular prism and the pentagonal prism that the sides that are not the bases are rectangles. So you always sides that are rectangles, it's the bases across from each other that are not rectangles that determine what the bases are and the name of the rectangular prism. It's a little different because that rectangle are different sides. So you could actually pick any two sides that are parallel to each other to determine the bases. So any two sides across from each other and parallel are the bases in a rectangular prism. The next type of figure we're going to talk about has one base instead of two. So these are called pyramids. But again, pyramids will be named based on the shape of its base. So a square pyramid has a square base, triangular pyramid has a triangular base, a pentagonal pyramid has a pentagonal base, etc. So you always have one base, a vertex, that there's a particular distance between the vertex and the base for pyramids. When we talk about surface area, what we're talking about is area every single side of a figure added together. So it's really just a bunch of areas added together. In this case, this is a triangular prism. If I was to fold it together, up here where I have an area of an 8, this is the triangle that would be on the top if we were to leave the figure in the rotation that it's drawn. On the bottom, we have an area of 8, and the other base that is a triangle. So our two bases are triangles, so it's a triangular prism. And then the rectangle that's an area of 12 and the rectangle that's an area of 16 would wrap around to connect with one another, and the two triangles would fold down. And this length right here, I'll use color, would connect with the top of the rectangle that has an area of 12, the same with this length right here. So these two lengths are the same, the ones in purple. Same idea on the other side of the 8. This side is going to fold down to connect with the top side of the 16. This side is going to fold down to connect with the bottom side of the 16. And this tall height of the 16 would connect with this tall height of the 12 to help you kind of visualize how this figure would be folded in on itself to become a triangular prism. And to help you visualize a triangular prism, let me just remind you this is what it would look like once it's folded, only I have it rotated up on its side. So the triangles are on the top and the bottom. So all we have to do is add these numbers together to find the total surface area, which is pretty easy. So it's going to be 16 plus 20 plus 12 plus 8 plus 8, and that gives me the surface area. So you're adding the area of each different figures, and that's the total surface area. We're going to do the same thing with our rectangular prism, and again, to help you imagine what this would look like, here's a rectangular prism. Our rectangular prism in this example is slightly different as to how it looks, and when you fold it down, a lot of times we're going to consider the 5 and the 5 as the bases, although it doesn't really matter. The 6 and the 6 could be the bases, the 10 and the 10, because they'll all be parallel to each other, and that's what determines the base. The bases are the sides that are parallel to each other. So this side will fold down on this side in purple. This is going to be the same because they're rectangles, so their opposite sides are congruent, and it will fold down on the top of the 6. And then this side is the same, and this side is the same, this side is the same, and that side is the same. And so they all fold down on top of each other. And the 10 will wrap around the back and fold and connect with this 6 so that the 10 becomes behind this 10, parallel to one another. And this may be a harder one to visualize. When the 10 comes around to the back, this is the top of the 10 that connects with the 5. Well, the top of this 10 is going to connect with the top of that 5. The bottom of this 10 is going to connect with the bottom of that 5, just like the bottom of this 10 connects with the top of the 5. So that's just to help you visualize this coming together to form a box or rectangular prism. But as far as finding surface area, that's pretty easy. You're just going to add up all these numbers. So we're going to add up 10 plus 6, 10 plus 6, plus 10 plus 6, plus 5 plus 5, which gives us a surface area of 42. Now, area is always units squared, so if I had given units, then these would be whatever units squared. So here's a rectangular prism that's drawn as the prism itself instead of a flat version of the prism. So what we're going to do here is find the area of each side. So we have the area of the front, which is going to be 4 times 2, which gives us 8. Now the front and back are going to have the same area. Then we have the sides, or excuse me, the top. So the top is going to be 4 times 3. So let's make sure we can recognize where that comes from. So this length here is 4 because that length is 4. And then we have a 3 here. So the top is 4 times 3, which is 12. The bottom is going to also be 4 times 3. They're parallel to each other and congruent. We have a length of 4 here and a length of 3 here, because those are congruent to each other. So the top and bottom will also be 4 times 3 each, which is 12. So then we have the two sides, which are going to be congruent to each other. So for the two sides, we have the left side and the right side. The left side is going to be this 3 up here times the 2 right here. So that's 3 times 2, which is 6. And over here it's the same, 3 times 2, which is 6. With a rectangular prism, it's pretty easy because the front and back are the same, the top and bottom are the same, and the left and right sides are the same. So you could kind of simplify this and say 2 times 8, 2 times 12, and 2 times 6 when you do your math. And that gives you your total surface area. In the next example, we're finding the surface area of a triangular prism. Again, we just want to find the area of every single side. So we're going to start with the bases. The bases are always congruent to each other. That's the definition of a base. And a prism is the two sides opposite of each other and parallel, and they're congruent to each other. So it's a triangle, so it's 1/2 times the base times the height. So the base and height are the ones that are perpendicular to each other. So this is our triangle on the top, so it's 1/2 times 3 times 4. 3 is perpendicular to 4, so that's our base and height, and that gives us 6. So we know that the bottom triangle has to be the same area. So that's 1/2 3 times 4, which equals 6 as well. Next, we're going to look at the 3 sides. This prism has 3 rectangular sides, so we're going to use length times width, or base times height, to find the lengths of the area of the sides. So we have a side that's 3 times 10. That's this side right here, length of 3, and then a length of 10. Our height is 10 on all of these, and that gives us 30. Then we have another side that's 4 times 10. Right here, and that gives us an area of 40. And then in the very back, we have an area that has 10 again as the height and 5 as the width. So back here, this area is 5 times 10, which is 50. And then we add those up, 6 plus 6 plus 30 plus 40 plus 50. I just doubled my base, which was 6. but you can see where I get the numbers from here, and that's 132. In our next example, we're finding the surface area of a square prism. Here, since we know that this is a square, this base is a square, we know that the bottom base is also a square, we can actually do some shortcuts with this. I have it written out the long way, but let's talk about some shortcuts. We know that the two squares are 3 times 3 each. We know the height is going to be 4 all the way around, so all 4 of the rectangles are going to be 3 times 4. So a shortcut would be to multiply the area of the two bases. So 2 times 9, and then all 4 rectangles are the same. So you just have to find the surface area of one rectangle and then multiply that by 4. So the two bases plus the 4 rectangles equals 66. Next, we're going to talk about surface area of cylinders. A cylinder has two bases that are circles instead of polygons, and they are parallel to one another and congruent as well. So the formula that you'll need to know is that the surface area equals 2 pi RH plus 2 pi R squared. So to kind of help you understand where this formula comes from, to make it easier to remember, let's break down the picture. We can see that a cylinder is made up of a circle at the top and a circle at the bottom, and we know that the area of a circle is pi R squared. And so, since they have the same area, they'll both have the same pi R squared, the same radius for each of them. And then we have the part that connects the two circles, the two bases, and if you unroll it, it's actually a rectangle. So it's really going to be base times height to find the area. However, the base is the same thing as the distance around your circle. The distance around your circle is circumference, and we know that circumference equals 2 pi r. So instead of writing base, we can just write 2 pi r, the circumference for this line right here. So the formula ends up being 2 of our bases, 2 times pi r squared, so that's from here and here, plus you're going to add to it the area inside your rectangle, which is the circumference times the height. So that's the circumference, 2 pi r, times the height, h. So that's where the formula comes from. And using it's actually really easy, because all you have to do is plug in numbers. So we're going to find the surface area of the cylinder rounded to the tenths. So in this case, we know that we have a radius of 2 and we have a height of 6. So all we have to do is plug in 2 for radius and 6 for height in our formula and just type it straight into our calculator. Nothing tricky. So I'm going to plug in to this formula was 2 pi RH. So I'm putting radius is 2, height is 6, plus there's 2 areas of circles, so 2 pi r squared, so I put 2 in the place of radius, and I just plug this straight in my calculator and get 100.5 rounded to the nearest tenths. My next example, I have a picture that represents a storage tank, and I want to paint it, and when you paint the outside of something, that's the surface area. A can of paint will cover 50 meters squared. How many cans of paint are needed? So first I need to find the surface area. So I'm just going to plug in what I know. I know that the radius is 6, the height is 5, radius is 6, so put all that in, round to the nearest tenths. Now, it takes, one can will cover 50 meters squared, but I have 414.7 meters squared. So I'm going to have to divide that by 50, and that's going to give me approximately 8 cans of paint. I'm going to have to round up so I have enough cans of paint.